Nice.
Huh?
Nice. Okay, this is the Secondary Math 3 Unit 2 review. The test that you'll be taking is broken up into two parts. There's going to be a non-calculator portion, and then you will have a calculator portion. The calculator portion will cover sections 4 and 5 when everything that we did was on the graphing calculator. So please make sure you know how to use your graphing calculator, because if you don't know how on those two sections, you will not pass. Okay, the first section talking about just this function. We need to be able to write a function in standard form. We need to be able to classify it, talk about its end behavior, turning points, increasing, decreasing. So before we can do that, we're given this vertex form of the polynomial. If I want to write this in standard form, I need to write it in the format ax squared plus bx plus c. To do that, I have to get rid of this. You kind of look at this like using the order of operations. You want to get rid of that x, or you want to simplify that x minus 3 squared. So it's probably easiest if you rewrite it. And then you'll just double distribute that or FOIL it. So you would have x squared minus 3x, then multiply down here, another minus 3x plus 9, combine like terms, x squared minus 6x plus 9. Now that's only the first part, the squared part. You still have this minus 2 right here, so let's tack that on to the end. So in standard form, once I simplify this, my function would be y equals x squared minus 6x plus 7. If I want to classify it by degree, the degree is a 2, so that is called a quadratic. Make sure you know what the others are: linear, quadratic, cubic, quartic, and quintic. If I want to classify it by the number of terms, there's 3 terms, so it is a trinomial. End behavior, you need to have this part memorized too, but as x approaches negative infinity, as x is going left, my y is pointing up. So as x approaches negative infinity, y approaches infinity. As x is going right, my y is going up again. So as x approaches infinity, y is also going to infinity. Informally, if I want to say this, I'm going to call it up and up. On the test, I don't need to know exactly where the turning points are. I just want to know how many there are. So in this case, the graph has been provided. There's one turning point. Now in order to do increasing, decreasing, I guess it is important to look where the turning point is. On the test, the turning point will be given to you, so you don't have to estimate anything. This turning point happens at 3, negative 2. And if I'm talking increasing, decreasing, I'm talking about the intervals in which my y value is going up and down. And when I say intervals, I'm talking about the domain. So what part of the domain is my graph going up, and in what part of the domain is my graph going down? It again is going to be all dependent on that turning point. So I like to draw a line down my turning point, and I like to write down what the x value is at that turning point. And that x value at 3 is going to be the number we're using on the increasing, decreasing. To the left of that line, my graph is going down, so that's a decreasing. On the left-hand side, so from negative infinity, it's going down. It stops going down once I get to the 3. At that 3, it starts going up, and it never stops going up, so to infinity. At the 3, it is not going up or down. At that exact moment, it's flat. That's the turning point. So I'm not going to use a closed bracket with these. I will be using an open bracket, because at that exact moment, at 3, it's neither going up nor is it going down. Okay, let's do this again. This bugger is a little bit harder. We need to multiply these two together, take whatever we get there, multiply it with this one, take whatever we get there, and then distribute the 0.5. So I'm sorry. Okay, let's do this. X times x, x squared, plus 3x. I decided to do the last two first. because I did. Minus x minus 3. It doesn't really matter which two you do, you just need to do two of them together. Simplify x squared plus 2x minus 3. Take that, multiply it by x minus 2. I'm going to kind of distribute backwards if that's okay. I'm going to take that x and multiply it this way. So you would have x cubed plus 2x squared minus 3x. And then let's take that minus 2, that negative 2, and do it again. So negative 2x squared minus 4x plus 6. Combine like terms. You've stacked those like terms nicely so that it's really quick to combine the like terms. And there you have it. But we have to remember that you have that 1/2 right here. So if I multiply everything by 0.5, in standard form, my y, it would be y equals 0.5 x cubed, and then half of 7. So you can say minus 7/2, or you can say minus 3.5x, and then half of 6 plus 3. The degree is a 3 this time, so that is a cubic. There's 3 terms, trinomial. Now look at the end behavior. What's happening is x is going to the left. Now it points for you. It's pointing down. On the left-hand side, it's pointing down, which means as x approaches negative infinity, y approaches negative infinity. Look at the right. What's happening? You don't have to look at the crazy stuff in the middle. Just at the very end, what's happening? It's pointing up. So as x approaches infinity, y is going to infinity. Informally, we're going to call that down and up. How many turning points are there? There are 2. And in order to do the increasing, decreasing, hold on. Okay, sorry. In order to do the decreasing and the increasing, we need to figure out where those turning points are. We're just going to estimate, because on the test, these 2 points will be given to you. They'll be written in by hand. So this right here, x equals negative 1.5, is my first turning point-ish. And this turning point right here happens at x equals, let's say, positive 1.5. So look at those different, we've split the domain up into 3 different chunks this time. On the very far left, the graph is going up, then it turns and goes down, and then it turns again, goes back up. So on that first part of the domain, I'm increasing all the way from the left, negative infinity. I stop increasing at my first dotted line, negative 1.5. At that point it turns, starts going down. So from negative 1.5, when does it stop? At the next marking that I just made, 1.5. So from negative 1.5 to 1.5, it's going down, then it turns again. From 1.5 to infinity, goes back up. Now if I have 2 sets right here, 2 pieces of the domain, we'll connect those together with a little union symbol, that U. Okay, that's section 2.1. Let's look at 2.2. 2.2, our whole goal is to add, subtract, and multiply, add, subtract, and multiply. On this one, we're combining like terms. If the add is right there, we don't need the parentheses at all. One thing to remember, I'll tell you in just a second. So this one, there's no 4x squared, so just 4x squared. When I'm done, I like to cross them off. That way I don't forget about them, and I don't add them in twice. Next set of like terms was the 3x and the 2x. If I'm adding 3x plus 2x, it's kind of like saying I have 3 apples and then 2 apples. I have 5 apples, right? I'm not going to call it an x squared, just 3x plus 2x. Those are gone. Minus 5 plus 4 is minus 1. That's it. Which should be a ginormous review because you've been doing that for a very long time. Number 4, do it again. I like to write these in standard form. If you would too, please, that would be helpful. So we're going to start with the cube. That's going to be our leading term. I've got 6x cubed plus 3x cubed. Total would be 9x cubed. Taking care of those. Then we're looking for any x squareds that happen. It's a minus x squared. There's only one of them. So minus x squared. Then we'll look for our x terms. There's two of them right there. Plus 11 minus 9 would be a plus 2x. And then plus 6. Subtraction is a lot like the add. The only difference is we need to subtract everything after the subtraction sign. So this entire grouping right here. Now if I continued on and said plus like 2x minus 3 or something, I'm not going to subtract this part. I'm only going to subtract the part that's in the parentheses. So only right here. Don't worry about that. What I like to do is yes, we're going to distribute that negative in. Sometimes it gets kind of tricky when you have this little tiny like symbol right here. It's easier to make the mistake. I like to rewrite it below. And then that becomes a plus 5x and that becomes a plus 6. And then I like to cross this off. It seems like you're less likely to make a mistake that way. Then we just look for the like terms. Looks like the leading degree will be a cubic. So that guy comes first. Then you have a minus x squared and a minus 2, which would be a minus a negative 3x squared. Gone. Negative 8 plus 5 would be negative 3x. Gone, gone. And plus 13. See that? Fantastic. One more time. So I've got this minus right here. So what do? We distribute it. Negative 5x cubed plus x squared plus 2. Ignore that now. Looks like our highest degree will be a cube. Combine the 12 and the negative 5 to make a 7x cubed. Again, remember the power, the exponent doesn't change when you're adding. Only changes when you're subtracting. Combine the negative 7 and the 1, so minus 6x squared plus 4x, there's only one of those, plus 2. We've taken the test and changed the numbers and added more examples. So if you can do what's on this review, you can do the test. Okay, so now we're going to do the multiply, which we've already experienced on the other page when we were writing that in standard form. So sometimes you hear it called FOIL. That's not actually a math term, it's just kind of a way to remember how to do this. Distribute, though, is a math term. Some people call it a double distribute because you'll be distributing the 2 and then you'll distribute the 1. So whatever, call it what you want. 2x times a 3x squared. This is where we will add those exponents. I have 1x here, 2 here, 6x cubed. Let's do it again. 2x times a negative x would be a negative 2x squared. And then 2x times 4 is a plus 8x. Good night. So you have to say good night to my husband because it's 11 o'clock at night and he goes to bed at normal times. And I don't.
Peace out.
Peace out. Apparently he knows I do that on the end of my videos. Okay. Random. Multiply that, you get 3x squared minus x plus 4. Combine like terms. Again, I really like to put those like terms in columns. It doesn't matter though. Plus 7x plus 4. Okay, next one. This you have 3 terms, so we will distribute the first 2. So you'll have 2x squared minus x plus 10x minus 5. 2x squared plus 9x minus 5. Take that, x minus 2, and then let's distribute that x 3 times, and then the negative 2 3 times. So you'll have 2x cubed, then here, plus 9x squared minus 5x. Now let's do it again with the negative 2. Negative 4x squared minus 18x plus 10. Add those together, 2x cubed plus 5x squared minus 23x plus 10. Okay, number 9, there's not very much room, so write small. So on this one, what we're going to have to do is we will need to combine those by addition. We'll combine those by the multiplication, and then we'll subtract what we get from the first and what we get from the second. So looking at the first group, looks like that 2x cubed will be my leading term, and then you have plus 5x squared, and then a minus 4 minus 6 would be a minus 10x plus 1. And then looking over here, minus, keep the parentheses because we want to we want to subtract the entire thing, not just that first term. Okay, what I'm going to do is I think I'm going to write it kind of small off to the side so that I can combine like terms off to the side and then write it right here. So x times a 2x would be 2x squared. X times a minus 3 is a negative 3x. And then the inside would be plus 2x minus 3. So we're going to subtract 2x squared minus x when we combine those middle two, minus 3. Because of lack of room, I may not rewrite this. Let's distribute that negative and make the 2 negative, the x positive, the 3 positive, and then the plus. And we're almost done. Okay, this is the only x cubed. That goes. Now I've got a 5x squared and a minus 2x squared would be plus 3x squared minus 9x plus 4. Alright, that's section 2. Section 3 is long division and synthetic division. Really quick, let's jump to number 13. When you set this up and something weird happens, so go ahead and skip this one. So we're only going to do those 3. Number 10. Alright, when we're setting up long division, write small because there's a lot to work, or get another sheet of paper. Okay, long division, we're looking at this first term here and we're looking at the x here and we're going to divide. If I were factoring out an x from the x cubed, what would I be left with? I'd be left with an x squared. So x cubed over x, again only looking at those first 2 terms, is x squared. Now we'll multiply. X squared times x is x cubed. X squared times 1 is x squared. And then we draw the line, change the sign. So this is our subtraction part that will cancel. Then we've got, subtract, you get 6x squared, bring down the 15x. And we divide again, only looking at these first 2 terms again. If I had the 6x squared on top and the x on bottom, the x's would cancel, so you'd have a plus 6x. Multiply 6x times x would be 6x squared. 6x times 1 would be 6x. Draw the line, change the sign. Subtract, you get 9x. Bring down the 9 and do it one more time. 9x divided by x is 9. Multiply, you get 9x. 9. Subtract 0. So our final answer is x squared plus 6x plus 9. So if the question said, determine if it is a root of the polynomial, you would say yes, because it goes in evenly, there's no remainder. Cool, let's do 11. X minus 4, 2x cubed minus 7x squared minus 7x plus 13. Alright, so divide. 2x cubed divided by a 1x would be a 2x squared. Because if I were to multiply this, 2x squared times x, I would get that 2x cubed. And I want to get the 2x cubed so that that first term will cancel. If that first term doesn't cancel, we don't get that kind of triangle thing happening where all of the terms go away. Like you want that x cubed and then the x squared and then the x to cancel so that you can be done with the problem. Now we're multiplying. So multiply that and then you'd get a minus 8x squared. Draw the line, change the sign, cancel those. Combine those, you would get x squared. Bring down the minus 7x and do it again. X squared divided by x is x, 1x. Multiply x times x is x squared. X times a negative 4 is a minus 4x. Draw the line, change the sign. Negative 3x. Bring down the 13. And then divide again. Negative 3x divided by x is a negative 3. Multiply. Negative 3x, multiply a positive 12, draw the line, change the sign, you get a 1. So is it a root? Is that factor a root? No, because there's a remainder. So how do we write that remainder? I'm going to rewrite the whole thing. So I've got 2x squared plus x minus 3 plus, because it's a positive 1 over x minus 4. Okay, number 12. Let's do this one more time. This time, notice I've got a 2x right here. Totally fine. Alright, divide 2x cubed divided by 2x. Well, the 2's will cancel and you're left with x squared. Multiply, you would get 2x cubed and then x squared. Draw the line, change the sign. Those cancel. 8x squared plus 14x. And do it again. 8x squared divided by the 2x. Well, 8 divided by 2 is a positive 4. And then x. When I multiply, I have to get 8x squared. And then 4x times 1 is a 4x. Draw the line, change the sign. Those cancel. You get 10x. Bring down that plus 5. And do it one more time. 10 divided by 2 is 5. X, good. So 10x. Sorry, if my hand's been in front of this the whole time, I apologize. I haven't even been paying attention. Those cancel, so you get a 0, which means my final answer is x squared plus 4x plus 5. Excuse me. Okay, the next one. Divide using synthetic division. State whether the factor is a root of the polynomial. So we'll be having a yes, no tacked on to these answers. Okay, to set these up, first of all, you want to make sure that each term is there. If each term is not there, you'll be placing a 0 in, and you'll use that as a placeholder. But I've got an x cubed, x squared, linear, constant, so we're all there. Now to set up synthetic division, you take the coefficients of the polynomial you're dividing into, and then in kind of a little box here on the side, you take this right here, and what value would make this 0? If I wanted that to be 0, wouldn't x have to be a negative 5? So we'll plug in a negative 5 right here. and then we'll drop down that 1. That first number always goes down, and then the pattern with this will be multiply, add, multiply, add, multiply, add. So I multiply those two, you get -5, add, you get 0. Multiply, you get 0, add, you get -1. Multiply, you get 5, add, you get 0. Now if you're doing this and you get some like wonked up answers, like some crazy numbers, you may want to erase and start over. Double check to make sure that this is the opposite sign as this, because that will give you some like psycho answer. Make sure all of your negatives are in the right place. Not always, but often my numbers are going to hover pretty small. You might get in the 60s, in the hundreds, 90s, somewhere in there, but you shouldn't be getting like 700s or whatever. So just, this seems pretty simple. Okay, now how am I going to rewrite this? I have this 1, 0, -1, 0. Well, I took a cubic and I divided out a linear, so just like up here, when I take a cubic and I divide out a linear, I get an x squared, right? So it's going to be 1x squared, and then a 0x, and then a -1. To rewrite that, I'm going to say x squared. I don't need the 0x, and just say -1. Because my remainder is a 0, state whether the factor is a root. I'm going to say yes. Okay, let's do it again. Now on this one I've got a cubic, a quadratic, but no linear term. So 5, 8, a 0 for my linear term, and then a -60. I take the 2 out front and bring down the 5. Multiply, you get 10. Add, you get 18. Multiply, you get 36. Add, you get 36. Multiply, you get 72. Add, you get 12. So, is it a root? No. How do I rewrite this? 5x, it's always 1 less than what you start with, so 5x squared plus 18x plus 36 plus 12 over what we divided by. Alright, do it again. 16. 1, okay, check for missing terms. Quartic, I don't have a cubic, so 1, 0, -5, 4, 12. A little bit bigger this time. Out on the outside, -2. Bring down the 1, multiply, add, multiply, you get 4, add, you get -1. Multiply, you get 2, add, you get 6. Multiply, you get -12, add, you get 0. Okay, oh my gosh, sorry. So, rewrite that, x cubed minus 2x squared minus x plus 6. Is it a factor? Yes. The reason we care if it's a factor, it doesn't really make a lot of sense right now, but it's going to make a whole lot of sense in Unit 3. We will be doing this, and we will be finding every single factor. If I gave you this, our goal would be to find every single factor, real or imaginary. That's kind of where we're headed. So we're starting small. Let's just learn how to divide. Let's decide if it's a root or a factor, and then we're going to kind of pump up the action here in just a minute. Okay, this one, I've got a quartic, but no cubic. I have a quadratic, but no linear. And then I have my constant. So that means I'm going to have a bunch of placeholders. Let's make that a 1. So there's my quartic, no cubic, quadratic, no linear, constant. Apparently we like the 2's today, so -2. Okay. Bring down the 1. Multiply, you get -2. Add, you get -2. Multiply, you get 4. Add, you get -2. multiply again, you get 4, add, you get 4. Am I right? Let me just double check. Multiply, -2. Yeah. Okay, I feel pretty good about this. Multiply, you get -8. Add, you get -35. So, x cubed minus 2x squared minus 2x plus 4 minus 35 over x plus 2. No. Sorry, there you go. Number 18, determine whether each binomial is a factor of that polygon. I'm going to add an instruction right here. Because you have to do that on the test. So if it is, then write as a product of two factors. Now, in class, we solved for x, and then we plugged that in to see if we got 0. We could do it that way. But if the answer is yes, and I have to write it as a product of two factors, that means I'm going to have to divide it to see what the two factors, or the two polynomials would be. So rather than doing what we did in class, let's just do division again. And if we had to choose between synthetic, which is like 12 numbers, and long division, which is 500, I'm going to choose synthetic because I feel like you're less likely to make a mistake. Okay, 1 times 2, 2. Add, you get 3. Multiply, you get 6. Add, you get -4. Multiply, you get -8. Add, you get 0. So, determine whether each binomial is a factor. The answer is yes. Write it as a product of two factors. Well, I multiplied it, or I divided it by x minus 2. When I got it out, x squared plus 3x minus 4 is my total. Okay, now somebody earlier said, well, this one works, which means this one can't, which isn't true. This polynomial has 3 solutions, so there's no reason that x minus 4 or x equals 4 couldn't be 1. So we're going to do it again. 1, 1, -10, 8. Put a 4 right here. Multiply, you get 4. Add, you get 5. Multiply, you get 20. Add, you get 10. Multiply, you get 40. Add, you get 48. Okay, well, it's not 1, but that doesn't mean it can't be. Or just because this one was doesn't mean this one can't be. But because that's not a 0, I'm going to say my answer is no. Alright, that completes the non-calculator portion. Nothing I did needed a calculator. Now we're getting into the calculator portion. My calculator's right here plugged in. It's working. Ooh, it's got battery life too. Okay, here we go. So in this one we're going to be using the graphing calculator to find all of this information and then plot the graph. So to plot it, whatever's in there, we're going to go, oh goodness, what's going on? Okay, hold on. A bunch of crazy. That's what happens when children play with calculators. I don't know. Okay, we're ready. So I need to graph this. X to the 4th, an arrow over, minus 5x cubed, arrow over, plus 5x squared, minus 3. Now who knows what this is going to look like? My window right now is, I'm just going to bring it back to this standard window. -10, +10. And then all of this stuff down here you don't really need to worry about. Okay, let's graph it. Okay, we almost have the full thing on the graph. We just need to look and see where that minimum is down here. Sorry, hard to see. So I'm going to increase the window. I don't need to change the Y min. I'm going to change the Y max, or just strike that, reverse it. I don't need to change the max, I just need to change the min. If I change it to 20, that means my scale right here, each little box will be worth 2. So I guess if you want to see on the calculator what your graph should look like on the paper, you would change that to 20 as well. Oh, that's cool. It tells you right here on my calculator at least what this little means. The Y scale is the distance between tick marks on the axis. Didn't know that. Let's make our box worth 2 each. Graph. Looks like on this I've got 2 zeros that we'll be trying to find, a relative max, 2 relative mins, and that's it, and then the y-intercept. So let's do the maximum first, this little hill right here in the middle. Everything that is going to be housed in this calculate right here. To get the calculate button, you'll click second and then calculate. You can arrow down or you can just push 2. Now it's asking for a left boundary and it's going to ask for a right boundary. You need to give it a window in where to look for the maximum. Mine's kind of cool. It draws this little dotted line, and so you can really see that that hill is in between my 2 dotted lines. Then it asks you to guess, but I never guess. Oh, I strike that. Okay, I got an error because it didn't see a sign change. Anybody see my error? Not that I know that you're answering. The error was when I went in, I chose 0, but I wasn't really trying to find a 0, I was trying to find a maximum. So I gave it the window from here to here, and my calculator said I don't see it crossing the x-axis right there, so it freaked out, said I had an error. Now that I chose maximum, now it's going to tell me my maximum. I'd like probably 2 decimal places on these, so the maximum happens at 0.87, comma, negative 1.94-ish. Do not round to the whole number. You'll get points deducted from your test if you round to the whole number. Holy cow, we're at 37 minutes. Let's keep going. Calculate. Let's do the minimums now. Option 3. I need to go to the left of that little valley right there. Push enter. And then I need to go to the right of the valley. Then we guess. Now this right here is a really, really small number. So small it's basically 0. So my minimum is at 0, negative 3, which is convenient because that's also the y-intercept. You can't see that. Okay, let's find this other minimum. So calculate minimum. I can push enter right here. Scroll all the way over. It's going to look for the lowest value, 2.88, comma, negative 12.217. Alright, the next one is the zeros. So I've got 2 of them. Calculate zeros. Okay, my 0 is about right here, right? So I just need that little blinking cursor to be the left of it, which it is. And then I need it to be below it. To move your cursor, you're moving the left and right buttons. So negative 0.590. Calculate 0. Because of the time, it's 11:30. I may not do all of these. Sorry. Okay, talk domain range. Domain is always all real numbers for these problems. For the left, it's going forever. For the right, it's going forever. The range, though, is not going up and down all the way. Now the range is going to start at that minimum point, which you just found to be negative 12.17. So it starts at negative 12.17 and then it goes up forever. And I always do this. That should be a bracket. I guess I'll know on your test if it's really bold that it is meant to be a bracket. Okay, let's graph this bugger. The trace button's really handy. I can put my kind of critical points in there, but I also can just trace at negative 2. Ooh, booger. Trace. Negative 2. Nope. Trace. What in the heck's going on? I have no idea what just happened. Okay, at negative 2, it's clear up at 73, so I'm not going to graph that one. At negative 1, it's at 8. Now don't forget my scale is worth 2, so I'm only going to go up to 4. My scale on this one, though, I kept at 10. It just means that my graph's going to be smushed a little bit. At 0, it was at negative 3. Let's see, the zeros are negative, basically 1/2, and then 3.7 right here. We got a maximum at almost 1 and almost negative 2. And then I have a minimum. I already graphed that minimum. And then this one is about 2, 4, 6, 8, 10, 12, maybe right here. For is at 13, 10, 12, 13, and that probably is enough to get me my graph. Note that it should be really steep coming in on the ends. I don't ask for perfect graphs. I mean, this is kind of ugly, but it needs to look like you gave it some effort. Put the arrows, make it go to the very top. If there's anything going on in this range and on this range, you'll probably get docked credit because the graph's pretty tight. Now if I look at this and look at that, is it perfect? No. But I would say it's a pretty good replica. Alright, 42 minutes. Whew. Let's do another one. Let's do one where, maybe number 21. No, I lied. Let's do 22. Let's do an odd function. This one was an even function. Let's do an odd function. Let me hurry and graph that. Negative x cubed minus 3x plus 1. So, ooh, this one actually is going to be a very quick problem because there is no max min. Because the graph kind of just snakes down and doesn't turn at all, which means no, that's not true. It only crosses one time. It only crosses one time, which means if I have 3 solutions, one of them is real because it crosses once. The other 2 are imaginary, and in a couple weeks we will figure out how to find those. I'm not going to lie, I'm really excited about it. Y-intercept. To find the y-intercept, I'm going to use the trace button. Okay, so at x equals 0, y is 1. The zeros, calculate 0. I'm on the left of the 0. I'm at the right of the 0. Guess, I never guess. 0.320. Domain, left and right goes forever. Range, up and down, goes forever. Okay, intercept is at 0, 1. 0.3. Okay, what's happening at 1? It's at negative 3. What's happening at 2? It's at negative 13, so it's off my grid. At negative 1, it's at 5, and I'm guessing at negative 2, it's way up there. So I just want to make sure my graph doesn't cross that negative 2 line. and I want to make sure my graph does not cross the positive 2 line. And there she be. Fast. Hopefully there's one like that on the test. That was brilliant. Okay, looking at the back. Our polynomial models, this is what we learned last time. 24 is a bugger problem. It's not written great. Let's just skip it. It's okay. Yeah. Okay, number 23. Write a polynomial function whose graph passes through the points, la da 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 da, round to 6 decimal places. Yeah, honey, we're rounding to 2 decimal places. Sorry about that. Okay, all of our regression information is going to happen in the lists, and we use a lot of lists when we're talking about statistics. So I'm going to go through the stat button, and really this kind of stuff is used by businesses. Businesses use statistics to create regression models to be able to predict things that are happening in the future. I'm going to use my data for the last 10 years, and I'm going to, pitch a proposal to my boss about why we need to make whatever decision. It's used all the time. Okay, so if I want to edit my list, holy Hannah, what's all in here? Don't do that. I just cleared out my list. Okay, what do I do when I don't know how to fix a problem? Sorry, it's late. It's late and I'm tired. I should be in bed. It's back. Good. Okay. You can come up here. So say you have a bunch of things in here. Let's see if I screw up again. You can come up to the L1. If you push delete, it deletes the entire list and L1's now gone. If you push clear and then enter, your list goes away. So delete, bad, clear, good. Okay. My X values goes here, 0, 2, 1. My Y values go here. I realized I just had a really bad grammar mistake. But again, it's almost midnight, and I'm doing this because I love you. Stat, calculate. There's 3 points. If I'm given 3 points, I could do a linear model, but a linear model won't be the best fit because I'm trying to get a line through 3 points. And unless they're all collinear, it's not going to work. But through 3 points, I can come up with a quadratic regression. Through 3 points, I can guarantee that the equation hits all 3 of them. And I know the equation hits all 3 of them. On some of your calculators, you'll have an r squared and an r. That r squared is telling me how close the data fits the points. And if it was ever a 1, that means it fits the points perfectly. So, anyway, okay, I've got my A, my B, and my C. So my formula, y equals 3.5 x squared minus 4.5, you can't even see this, x plus 5. That's it. Number 25, find a linear, quadratic, and cubic model for the data. Really quick, I'm going to show you, most of you, how to turn on the r squared. If you're watching, by most of you, I'll use that term lightly. But on here, there's a bunch of, I clicked mode, and there's a bunch of different options, I guess. A lot more than I'm used to seeing. So if you go all the way down, there's a stat diagnostics. Mine's off right now. I can turn it on. And I'll show you what that does. So I need to edit my data. Let's go, so 3, 8, 15, 21, 7, 11, 26, 44. So maybe I didn't do a very good job explaining. Through 4 points, I can write an equation, a linear equation, that will try to fit those 4 points as close as possible. What will happen is, if I have the 4 points kind of looking like this, the line will probably come up like that. And it doesn't quite touch them all, but these distances will be kind of the same top and bottom. I could put a quadratic through it, but again, it may not fit it perfectly. but I know since there's 4 points, a cubic will fit it perfectly. So let's do each of these first. So if I want a linear model, we go to Stat, Calculate, Linear Model, and my equation is y equals 2.08x squared minus 2.5x plus, oh, that's it. Oh, hold on. Backtrack. It's linear. I got really excited there. Y equals 2.08x minus 2.5. Now notice the r squared is 0.957, yada yada. I mean, that's a good fit, 0.95, I would say. It's close to 1. But I wouldn't call it a perfect fit. So, okay, let's do the same but quadratic. Stat, calculate, quadratic. There we go. So the formula here, y equals 0.086x squared plus 0.0089x plus 5.96. On this one, my r squared is 0.999. Again, a really good fit. Is it a perfect fit? No, because it's not a 1. Okay, one more time. Stat, calc, a cubic regression. Now through any 4 points, I know that I can draw a cubic regression. It will hit every single one of those. So I expect my r squared here to be 1, indicating that it's a perfect fit, and it is. That's a perfect fit. So negative 0.0026 x cubed plus 0.18x squared minus 0.91x plus 8.2. R squared equals 1. So, answer the question, which model best fits the data? The cubic. The reason? Okay, people, that. Through any 4 points exists a cubic model. We can, through any 4 points, I can give you a cubic formula, and it will fit every single one of those points. Quadratic, it's not likely. It's possible, but it's not likely that it will fit every single one of them, which is why my r squared is almost never 1 with a quadratic if I'm given 4 points, and even less likely if it's linear. It's not a bad fit, it's just not a perfect fit. Okay, so now we're going to answer this question. It tells us what to do. Use a cubic model for the data below, then use the model to estimate the population in 2008. And it will tell us right here, let x be the number of years after 2000. That's kind of a big deal. So if I were going to label my x, if 2000 was my starting year, I'm going to x equals 4, 7, 9, and 10. Stat, edit, try this again, clear, 4, 7, 9, 10. Okay, then what? We are almost done, and I'm really happy about that. Never done this at home before. Okay, this time I want to store my regression equation because I want to be able to use the data to make an estimation. To do that, we're going to go to the variable button right here by the, if you can see that, right here by the down arrow key. We need to stare it with our y variables into a function. We're gonna, it doesn't matter which one you choose, but y1 is kind of standard. Now I'm going to show you two things. One, we have the equation. What will it be? Y equals. Now make sure you're checking for the times or the e negative 5 or the e negative 2 or something. There you have it. Because if it has an e -2 or e -3, I want to make sure the appropriate numbers of zeros is before that cubed. Alright, if I want to find out what the function is doing, it says in 2008. So the function at 8. I should have stored it, so my function's in there. Notice that that's not rounded. On my paper I rounded, right? On this it's not rounded. If I graph it, I don't even know if I'll be able to see it. Probably not, because my data is in the like thousands, right? So if I wanted to actually see the graph, I'm probably going to have to increase my window to maybe 1500. I don't know. Interesting. Okay. Cool. Now if I want to estimate what's happening, I want to find out, again, we're looking at year 8, so we're going to trace, see what happens in year 8. In year 8, I'm at 1097.3, what is it, population? Population where? We don't know, just the population of something. Something else that's kind of cool, there's a table, so the second graph is a table. And it gives me all of that data. So if you didn't want to like trace it, you could use the table and just find it in the table as well. It's all there. That regression model probably only works for some time because, interestingly enough, look at that. When you get past year 15, it's saying our population is going negative. Which probably doesn't make a lot of sense. Okay. Last one. The height and width of a rectangular prism are each 2 inches shorter than the length of the prism. So let's just start by drawing a picture because yeah, prism. So the height and width of the rectangular prism is 2 inches shorter than the length of the prism. So if the length is x, then it's 2 inches shorter. I've got an x minus 2 and x minus 2. This one's a hard one. And then it says the volume of the prism is 40 cubic inches. So how do you set that up? How do I find the volume? I've got x times x minus 2 times x minus 2 equals 40. Approximate the dimensions of the prism to the nearest hundredth. Wow. Okay, so let's start. I'm guessing that we're going to want to do synthetic division with this and rewrite it as a product of factors like we've been doing in the past. But in order to do that, we need this to be all multiplied out and we need the 40 over. So ignore the x for now. I'm going to do it quickly. X squared minus 2x and then minus 2x plus 4 would give us x squared minus 4x plus 4. Now if I distribute that x, I will have x cubed, you see that, minus 4x squared plus 4x equals 40, right? So if I were to subtract both sides by 40, this is the equation I would get. Now, I can take that equation. I don't have to do it by hand. I can plug it into my graphing calculator. I probably don't need my window to be at 1500 anymore, but maybe negative 50 to positive 50, and I say that because that last number is negative 40. Let's see what happens. Okay, what I want to do is I want to find my zeros. Oh my goodness, I don't even know if this one's going to work. There's only one zero, right? What does x equal? Okay, let's try this out. So, let's calculate my 0. I don't know how much I love this problem. Excuse me. Oh yeah, I'm high enough. So my solution is x equals 4.9. Is that okay? That's where my solution is 0. I solved it, set it equal to 0. X equals 4.9. So going back to our equation, this is our box, right? Which means this dimension right here, 4.9. This dimension right here is 2.9. This dimension right here, 2.9. That's what you do. We will get into questions that are more applicable like that on Unit 2 or Unit 3 that's coming up. But that's kind of a heads up on how you do it. Alright, well, it is almost midnight. Thank you for watching. Hopefully it's not almost midnight for you. Good luck on the test. On the test you have a bonus question. After the bonus question, if you tell me what my favorite color is, then you get an extra bonus point. And that is proof that you watched my video, perhaps to the end, all 100, no, not 100, all 60 minutes of it. So my favorite color is fuchsia, the color of my calculator, the color of my backpack, the color of my favorite sweater. Really like that, not quite purple, not quite pink, fuchsia color. Okay, that's it. Thanks for watching. This is the actual peace out. It is late and I'm going to bed. See you later. Bye.